Hello everyone, welcome to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. So today we are going to look at Calculus 2 and our topic is the T method of substitution. Now, when do we use this method? It is used when our integrand is a rational function with the cosine or signs in the denominator. So that's when you need to use the T method. And we are going to consider two forms of integrals. The first one is the integral of the form where the integrand is 1 over a constant a plus another constant b sine squared x plus another constant c times cos squared x. A, b, and c, those are constants, or we call them real numbers. When I write R, this one means the set of all real numbers. So when you have this form of integrals, how are you supposed to start? We are going to say let t be equal to tan x. So that is the substitution that you need to make when you have such kind of integrals where the denominator consists of maybe sum of sine squared and cosine squared. So because we'll need to know what is sine squared x and what is cos squared x, given that t is equals to tan x. So we need to differentiate and find the x. What are we supposed to substitute in place of the x? When I differentiate this one, I'm going to get dt over dx. The derivative of tan x is the same as sec squared of x. But what is sec squared x? Remember the trigonometric identity that sec squared theta is the same as 1 minus tan squared theta. So this can be written as 1 minus tan squared x. And we know tan x is equals to t. So when you square that, you get t squared. So we'll have 1 minus t squared. That is dt dx. And so here you can now make dx the subject. So we'll have dx is equals to dt over 1 minus t squared. So that's what we have as the corresponding differential. So we start by saying let t be tan x, and then when you differentiate, you get dx is equals to dt over 1 minus t squared. Our task is to convert the integrand to a function of t instead of a function of x. So we must know what do we substitute in place of sine x squared and what do we replace or substitute in place of cos x squared. So to get sine x and cos x, I am going to use SOHCAHTOA. So we write using SOHCAHTOA, SOHCAHTOA will give you the ratios. If it is sine, it is opposite of hypotenuse. Cosine is adjacent of hypotenuse. And tangent is opposite over adjacent. So let me come up with a triangle, a right angle triangle of this form. Now we know we are given that tan x is t. That can be written as t over 1, so that the opposite is t and adjacent is 1. So our angle there is x, opposite is t because tan x is equals to t, adjacent is 1. As I told you, t can be written as t over 1. so that we know the opposite and adjacent. So to get the hypotenuse, we are going to use the Pythagoras theorem. Remember, hypotenuse squared is equals to base squared plus height squared. So when you want to find hypotenuse, you take square root on both sides. So this will give us the square root of 1 squared, which is 1, plus t squared. And so that is our hypotenuse. So from this triangle, it is now easy to know sine x and cos x. So sine x from our triangle, this will give us opposite of a hypotenuse. Our opposite is t. Hypotenuse is the square root of 1 plus t squared. So when you square both sides, you get sine squared x being equal to t squared over 1 plus t squared. So we have that. Again, from our triangle, it is easy to get cos x. The triangle, remember, cosine is adjacent over hypotenuse. Our adjacent is 1. Our hypotenuse is the square root of 1 plus t squared. So that's what we have. Now, we need to square that to get cos x squared, or simply cos squared x. So I'm going to square this so that I have cosine squared x will be equal to numerator, that is 1. 1 squared is 1. Denominator will give you 1 plus t squared. So now we know what we need to substitute in place of sine squared x and also cos squared of x. You see, we have expressed sine squared x in terms of t and cos squared x in terms of t. And we also know dx in terms of t. So that when we substitute back into our given integral, our new integrand will be a function of t, which is now easy to integrate. So I just wanted to show you how to convert those functions of x in terms of the new variable t. So we look at some examples. Maybe 2 examples will be enough. To start with the first example, we call it A. Let me write it. In example A, you are asked to evaluate. So you write part A. Of course, these are examples. In example A, you are asked to evaluate the integral of 1 over 3 plus cos squared x. Dx. So we know the substitutions. What we do here, I don't need to derive again because I've shown you how to express those functions of x in terms of t. So what you do, you say let t be equal to tan x. That is the substitution. Let me bracket this. So when t is equal to tan x, we have found that dx will be equal to dt over 1 plus t squared. That's what we have found. And we have also found cos squared x. We have also found cos squared x in terms of t, and that is 1 over 1 plus t squared. So let's work out the denominator. Now what I want in the denominator is now 3 plus cos squared x. 3 plus cos squared x. And what should it give us? It is the same as 3 plus 1 over 1 plus t squared. Let's combine this to one fraction. Remember, this is the same as 3 over 1. So the LCM in this case is 1 plus t squared. And then we'll have 3. 1 will go there. 1 will go into the LCM, 1 plus t squared times. So we multiply by 3. So 1 plus t squared, then plus 1. If I work out the numerator, I'm going to get 3 plus 3t squared plus 1, which is the same as 4 plus 3t squared. In the numerator, denominator is 1 plus t squared. Now, the reciprocal, what is 1 over 3 plus cos squared x? Now we want 1 over 3 plus cos squared x. That will give us just the reciprocal of what we have there. That will give us 1 plus t squared, everything over 4 plus 3t squared. The reciprocal. So now that's what we need to integrate with respect to x. And you know, even the dx, we have to convert it to dt. So when you substitute this into our integral, what are we going to get? So therefore, this integral, the whole of that integral will now become the integral of 1 plus t squared. Let me use a bracket here, over 4 plus 3t squared. And instead of dx, I'm going to write dt over 1 plus t squared. So our new integrand depends on t. You see, this will cancel with this other one. If we simplify that, we remain with the integral of 1 over 4 plus 3t squared dt. See, this now is very easy to integrate. Now you go back to the radicals. When you have 1 over a constant squared plus a variable squared, how do you integrate it? Use trigonometric substitution. Remember what we did? The tan. When we said when you integrate 1 over x squared plus a squared, said x should be equal to a tan theta. So in this case, our a squared is 4. So our a will be 2. So we are going to say that let me write it down. Just a minute. You're going to say that let, can use a different color. Let root 3t, or simply let t be equal to, remember it is a tan theta. What do you think is our a in this case? Is it 2 over root 3 or is it root 3? Let me show you how to get it. For you to get it, you will have to factor out 4 so that you have 1 plus 3 over 4 t squared. So you will say 3 over 4 t squared is the same as tan squared theta. 3 over 4 t squared is the same as tan squared theta. So when you take the square root on both sides, you get root 3 over 2 t is equals to tan theta. So make t the subject, That will be 2 over root 3. 2 over root 3. Tan. I hope I've explained how to get that. That we wanted 1 plus something. So I had to first of all factor out 4 so that we have 1 plus 3 over 40 squared. So the 3 over 40 squared is what you say, let that be equal to tan squared theta. And then you make t the subject. So when you do that, you're going to get t is equals to 2 over root 3 tan theta. So I need to differentiate this one so that I know what is dt d theta. So from here, when you differentiate, you get dt d theta being equal to 2 over root 3 times, when you differentiate tan theta, you get sec squared of theta. So, and now you can make dt the subject. So this means that dt is equals to 2 over root 3 times sec squared theta d theta. So you see the substitutions. We are going to substitute this and that one in this integral. So this integral now, when we substitute, it will give us this. It will give us the integral of 1 over, remember we have 4 plus, you square t, you get 4 over 3 tan squared theta, then times 3. Remember 4 over 3 tan squared theta, then you multiply by 3. The 3 will cancel. So here we are going to get 4 tan squared theta times our dt is 2 over root 3 sec squared theta d theta. Now again, we need to know the identity. You see, in the denominator, I can see 4 is common, and in the numerator, you can factor out 2 over root 3. So when we do that, what are we going to get? We are going to get this. It will be equal to 2 over 4 root 3 times now the integral of 1 over 1 plus tan squared theta. Now there we have sec squared theta d theta. So now, you know, 1 plus tan squared theta is the same as sec squared theta. So this will cancel with this. So that even the 2 will cancel with the 4, so that we have 2. So our answer will be 1 over 2 root 3 times the integral of d theta, which is the same as 1 over 2 root 3 theta plus a constant c. That is our answer. But you have to replace theta. So check where we have defined theta and make it the subject. You see, our theta was defined here. Let me bracket it so that we all see. This is where we defined our theta. So let's make theta the subject. From here, of course, I'll multiply by root 3 over 2. So it means root 3 over 2t is equals to tan theta. Then you take tan inverse on both sides so that we get theta is equals to tan inverse of root 3 over 2 times t. So that's what I'll write in place of theta here. So I'll come back and write this as is equals to 1 over 2 root 3. Instead of theta, we'll have tan inverse of root 3 over 2 times t plus a constant c. But again, you have to replace t. What did we say t is equals to? Remember, we started by saying let t be equal to tan x. So in place of t, I am going to write tan x so that our final answer will be equal to 1 over 2 root 3 times tan inverse of root 3 over 2. Instead of t, that is the same as tan x, then plus a constant c of integration. So again, this is very simple as long as you know where to start from. So I'm going to give you another example, part B, but this will be your exercise. Let me give you the hint. If I give you the hint, let me write down part B. Part B, you are asked to evaluate this integral. It is the integral of 1 over 2 sine squared x, 1 over 2 sine squared x plus 4 cos squared x, 4 cos squared x dx. So what you do here, you need to know what is dx in terms of t, what is cos squared x in terms of t, and what is sine squared x in terms of t. And already we have derived those functions of x in terms of t. So this is the hint. The hint to be able to evaluate this is you start by saying let t be equal to tan x, so that dx will give us dt over 1 plus t squared. What about sine squared x? Sine squared x, where the sine squared x we are going to put t squared over 1 plus t squared. That's what we got. And we also got cos squared x to be equal to 1 over 1 plus t squared. So make these substitutions here and then simplify. Once you simplify, your integrand will be a function of t. Then use trigonometric substitution to be able to integrate it. So when you do that one, I want you to confirm with the answer. The answer for this one, this should be your exercise. You try it. Just the same thing that I've done in part A. So the answer here, you need to get 1 over 2 root 2. 1 over 2 root 2 times tan inverse of 1 over root 2 times tan x plus a constant c. So I believe you can do this. Thank you all for watching. This is the end of this lecture. Don't forget to subscribe to my channel. Also, don't forget to share, you like and comment on this video. Bye bye.